k. Very easy. So let me get this done. So I'm leaving this here for reference so that we can jot it down and then take note of it. So let's go back to this. So since we have 1 plus k over s plus 3 s plus 5, which is equal to 0, so we can say here, in doing the round down work, we can say k plus s plus 3 s plus 5 equal to 0. So here again, we are going to expand the bracket. So we can say k plus, in expanding the brackets, I'm going to break that down for you so you understand. So we can see s here, this multiplied by this gives you s squared, this multiplied by this gives you 5s, this multiplied by this gives you plus 3s, and this multiplied by 3 multiplied by 5 gives you 15, equal to 0. So here again, we multiply this s through whatever is there. So we have k plus s cubed plus 5s squared plus 3s squared plus 15 equal to 0. So we can look into the equation right now we have here. We can see 5s squared and 3s squared they look alike. So we can say k plus s cubed plus 8s squared plus 15 equal to 0. So right now we have a final equation which can help us find the value of k. So we can see we can group like terms together. So in grouping like terms, we can say k is equal to minus of 5 cubed plus 8s squared plus 15 plus 15. Yes. So since we are done with this, let's take this off here. Let's take this off here. So sorry, we have to add the s sorry, let's go. The s which is multiplied by here should multiply by the 15. So we have 5s here, 5s here, 15s, sorry, 15s instead, 15s instead of 5s. So we can say we can leave this here for now. So we can leave this here for now and write it somewhere else so we don't mess up. So we can 15 cubed minus 8s squared plus 15s. So we can leave this here for reference because we'll come back to it. So let me get this cleaned. Transfer functions are really complicated, but then it just needs constant practice and studies to make everything sufficient for you. So let's go back to our question. So since we found our k value and we know k is equal to this, then we can say we can find the number of it's really difficult to pronounce. And then the number of asymptotes instead. Asymptotes. It says the number of poles minus number of zeros. You know, we said a pole is a denominator of a transfer function, which is equated to 0. So we found our poles to be 0 minus 3 minus 5. So we have 3 poles here, and we had infinite zeros which are 0. So we can say the number of asymptotes here. So we'll pronounce it as asymptotes is equal to number of poles minus number of zeros. So we have 3 minus 0, it gives you 3. So asymptotes are the number. So the number of asymptotes in the equation is 3. So we go to find the angles of asymptotes, which is equal to we can say this is QK, which is equal to 2K plus 1 times 180 all over number of poles minus zeros. So we can say that where we know K, where K can be 0, since we've not found the value of K here, we can say K are just like numbers. So we can say 0, 1. So we can say P minus 0 minus 1. Yeah. So here we can see this 60 degrees. It's an angle, so we have to choose angles which can match for us to get the angle of asymptotes. So you can see Q1 equal to 180 and then Q2 equal to 300. Yeah, and then so we have to go ahead and find the centroid, which is summation of poles, summation of just zeros over number of poles, number of distance. So we have minus 3 minus 5 all over minus 8 over 3, which gives you minus 2.67. So the number of poles multiplied by